All right, guys, today we're going to take a look at some more rates and accumulation type problems. We've kind of talked about this before, but I want to kind of go towards more specific type problems that are dealing with this rates and accumulation and area to approximate an integral type thing. I feel like this is definitely an area where some people struggle, not because the problems are super difficult or it's hard to type anything in the calculator. What is difficult is sometimes just interpreting what the questions are asking you and how to find that answer and why you can use maybe area or a definite integral to approximate things. Okay, so first one here, a cup of tea is cooling in a room that has a constant temperature of 70 degrees Fahrenheit. If the initial temperature of the tea at time t equals 0 minutes is 200 degrees Fahrenheit, and the temperature of the tea changes at the rate R of t equals that big equation, degrees Fahrenheit per minute. What is the temperature to the nearest degree of the tea after 4 minutes? Okay, so here's what we want to think about. R of t is the rate of change of the temperature. Rate of change, remember, is derivative. Okay, so a rate we can take the integral of to find the total amount. And remember, integral is accumulation. So if we take the integral of the rate over a certain time period, that's going to give us the accumulation of the temperature change in this case, depending on how long we want it. In this case, we want to go from 0 to 4. So here's what we need to think about. We know that the initial temperature is 200. So we want to keep in mind that 200, and then we want to add to it however much the temperature changes, that total accumulation of change from 0 to 4. Okay, and we're taking the integral of the rate. Remember, rate is derivative. Integral of the rate would give us the amount. So depending on which calculator you have, you can use your 84 for this. You can use your TI 89. Let's go to math, and number 9 is our integral. This one may look a little bit different to yours. You may have the pretty print, so just bear with me. Negative 6.89 times, what do we got? E, oops, I didn't get my E. Second, there we go. E to the negative 0.053, and I'm just going to use X as my variable. Okay, comma X, comma 0, comma 4. And again, if you have the pretty print where it comes up already in an integral, you can just fill that in as necessary. Okay, when we do that, 200 plus that integral, we get 175.165. Now, it's said to the nearest degree, so that would be 175 degrees. Okay, again, we need to get used to that integral representing the accumulation. Okay, and we know this is not changing direction because it's an E. E is not going to change direction. Okay, all right, next. Here we have a graph of velocity from 0 to 8 seconds. And we want to find the estimate of the distance traveled by the car from t equals 0 until the car comes to a complete stop. Okay, so what we need to think about is the fact that when a car comes to a stop, when anything comes to rest, that's when velocity is equal to 0. And we can see that that happens at t equals 8. So we're looking for the total distance the car travels from t equals 0 to t equals 8. Okay, so we're going from 0 to 8. Okay, all right, so think about this. We just said that integral gives us the total amount, right? And so if we have velocity, we need the total distance, then we need the integral of the velocity on this interval. Okay, velocity is the rate of change of the position. So if we take the integral of velocity on that interval, that gives us the total change. Okay, now we don't have to worry about changing direction. We can tell that the velocity is not changing signs, so we don't have to worry about a change in direction or anything like that. We're only looking from 0 to 8, which is all positive for velocity, so we don't have we do not have a direction change. So here's what we want to think about. We know that an integral can approximate area, right? Integral gives us area. So if we want the integral from 0 to 8, we can approximate the area underneath this curve. Look at the area underneath this curve, and we're going to try to approximate it. So let's look at the little, they're not actually squares because they're 1 by 10, but let's look at these little squares that would be filled in. There's 1 that's almost all the way filled in. These are, that's up to 4. That's 7, 11. We're at 16. Now notice this is a tiny little amount, and there's only a tiny amount left here. That gets us up to 17. Here's a tiny little space. That gives us up to 18. Okay, it looks like this. And maybe one of these, 19. These might fill in for 20. And then our little extra spaces through here, around 21 squares total. So that looks like around 21 of those little squares total filled up. And remember, they're 1 by 10, so they're 10. Their area is 10. So if we do 21 times 10, that gives us approximately 210 feet that the car traveled. Okay. A lot of times people think, how could this be this easy? How in the world could I be doing calculus and just be counting up squares underneath a graph? But honestly, that's what we're doing. Okay, that's finding the area, the approximate area underneath that curve on that interval 0 to 8 in order to approximate the integral, which would give us that total distance traveled. Okay. All right. Okay, so example 3, they give us the rate at which oil is leaking from an automobile. That's that L of T. For time T is greater than or equal to 0. It's measured in liters per hour. T is measured in hours. How much oil leaks out of the automobile during the first half hour? Okay, if T is measured in hours, then we're only going to a half an hour. So again, the integral is accumulation. So we want to find integral from 0 to 0.5. That's that first half hour of L of T. And that'll give us the total amount that leaked out during that time. So let's go over to our calculator. Now, one big thing, make sure you are in degree mode, in radian mode, which you should be on your 89, but some of you have to switch back and forth in your 84s, depending on what classes you have. So just make sure if you are on your 84 that you are in radian mode, because we are dealing with trig. So let's find the integral of 1 plus sine of x or t squared, however you want to do it, and then comma x or t, depending on whatever your variable is, comma 0, comma 0.5. And that gives us 0.541. Okay, so that matches up with D, 0.541 liters. Okay, all right, next one. The next one is more just an integral property, but I wanted to make sure we've talked about it before, okay? Because we are looking here, we have f prime of x given to us, and we want to find f of 2, and they give us an initial condition. Now, a lot of times we would think, oh, I can just take the integral, I can use the initial condition to find my c value, but the problem with that is this is not an integral that we know how to take. We can't take the integral of cosine of x squared. This is one that must be taken as a definite integral. If you try to put this even in your 89, you're not going to get an integral. Okay, it's not going to give you that integral function. So this is one, and this is a very common type of problem on the AP exam. So I want to make sure we've talked about it. Here's what I want you to think about. Let's say that we were taking the definite integral from 2 to 3 of f prime of x. Okay, that would be equal to value of f of 3 minus the value of f of 2, right? Because the integral of f prime is f. So we already know the value of f of 3. That's 7. Okay. Also, some of you might be sitting here going, well, how did you pick 2 and 3 as your bounds? Well, think about what we had. The only x values that we had were 2 and 3. So that's why I picked those. Okay. Now, if we want to solve for f of 2, we have f of 2 subtracted over here on the right. So let's add that over. And then let's subtract the integral of 7 minus the integral from 2 to 3 f prime of x dx. Okay. So let's just type that in our calculator. 7 minus the integral of cosine of x squared, and then comma x, comma, what are we going, 2, comma 3. That gives us 6.759, which matches with D. Okay. I feel like we've got a lot of D's in here so far. So again, we can set this up. Even though this is an integral we can't take by hand, we can turn it into a definite integral and use it to find a value. Guys, these problems are super common, so make sure that you understand how we did that and how we set that up. Okay, so now we're going to take a look at a free response question. Okay, penguin population is a differentiable function p of time t. P of t is the number of penguins, t is time in years for 0 to 40. 100,000 penguins on the island at time t equals 0. Birth rate for penguins on the island is modeled by b of t, so that's the rate they're being born at. And death rate is modeled by d of t, so that's the rate that they are dying at per year. Okay. Part A, what is the rate of change of the penguin population at the time t equals 0? Okay, so here's what we need to think. Rate of change of penguin population, that would be p prime, right? We want p prime of 0. If we want p prime of 0, rate of change of the penguin population at time t equals 0, then that means that we need to take the rate at which they are being born, b of t, in this case we're doing b of 0, minus the rate at which they are dying at time t equals 0. Okay, if we do that, if we plug in 0, these are e, so that's easy. E to the 0 is 1, so we have 1,000 minus e to the 0 is 1, again for the d of t equation, 250, and so that gives us 750. And then think about your units, penguins per year. Okay, so that's the rate of change of the penguin population. Now, let's scroll this down just a little bit for us. To the nearest whole number, what is the penguin population? Put two things together there. Penguin population on the island at time t equals 40. Okay, so here we are trying to find that population at t equals 40. So here's what we have to think about. Okay, well, we already know that there were 100,000 to begin with. Okay, and we want to add how many were born. So we have the rate at which they're born. That's the b of t. So we need to take the integral from 0 to 40 of b of t. And then we need to subtract how many are dying over that time period. So we need to subtract the integral from 0 to 40 of the death rate. Okay, so if we do that, we've got 100,000. There we go. Plus, and we want to take the integral of b of t, which was 1,000 times e to the 0.06, I'm going to use x for my variable, comma x, comma 0, comma 40. Oops, I missed a comma. Comma 0, comma 40. And then we want to subtract the integral of d of t, which was 250 times e to the 0.1 t, which I'm using x, comma 0, comma 40. We could put that all together in one integral if we wanted to. And that leaves us with 133,000. And let's see, let's round down because these are talking about penguins. They're living things. So 133,057 penguins are on the island at time t equals 40, which is 40 years. Okay, so again, we had to recognize b of t is a rate of the birth and d of t is a rate of death. So we had to add the rate of birth for the integral of the rate of birth for 0 to 40 and subtract the rate of death from 0 to 40. Okay. All right. I kept our information here. There's two more parts. Part C The nearest whole number, what's the average rate of change of the penguin population? So average rate of change, think about what we just said. We said rate of change, P prime of t, was B minus D, right? Okay, so if we want to find the average of that, we need to take 1 over B minus A, which would be integral, and then times integral. Oh, I can't talk. Okay, 1 over B minus A, so 1 over 40 minus 0 is just 40. Integral from 0 to 40 of P prime of t, which would be B of t minus D of t. So let's plug that into our calculator. 1 divided by 40 times the integral. We want to subtract. We want to take B of t, 1,000 times e to the 0.06. I'm using x, minus 250 e to the 0.1, and again I'm using x, and then we want to say comma x, comma 0, comma 40. So that would give us, okay, 826.44. So let's see, let's round down. Did they say to the nearest whole number? Okay, so 826, and then that again would be penguins per year. Okay. Last one, again to the nearest whole number. I need to pay attention to that. Nearest whole number, find the absolute minimum penguin population and absolute maximum penguin population on the island for T 0 to 40. Okay, so a couple of things here. First thing we need to do is figure out if there's a place where we have a relative max or min. So we're going to have to find out if P prime, it's supposed to be P prime, is equal to 0 anywhere. So we're looking to see if B of t minus D of t is equal to 0 anywhere. So I would probably graph this and find out if it's equal to 0 somewhere, and it is. It's at t equals 34.657. Okay. Now, what we need to do at this point is plug in our intervals 0 and 40, okay, to find the population then, and also check the time 34.657. Okay, so here's what we need to think about. I don't know if I'm going to have enough room. Okay, so P of 0, we already know that population is 100,000, right? Okay, P of 40, we just found that. We said that was, did we find that? No, we didn't. We found, yes, we did. That was 133,057. We found that in part B. So we've already done part of our work. The last thing that we need to find is the population at 34.657. So that would be 100,000 plus the integral from 0 to 34.657 of the B of t minus D of t. So let's put that in, 100,000 plus the integral. We've got to take B and subtract D. 1,000 times e to the, I didn't get my e, times e to the 0.06x minus 250 times e to the 0.1, and in this case I'm using x, comma 0, oops, forgot my comma, come on, comma 0, comma, what did we have, 34.657. Okay, let's find this number. That gives us 139,166 penguins. Okay, so we can tell that the absolute minimum, okay, on this interval, whoa, I did not mean to do that. Oops, I lost it. The absolute minimum is 100,000, right? Absolute minimum is 100,000 penguins, and the absolute maximum is 139,166 penguins. Anytime they ask you to find the max or min on an interval, you have to check the endpoints because those are numbers at which these go to. So you have to check your endpoints, and then you also have to make sure to check any relative maxes or mins that are on the interval as well. So that's why we had to solve for where p prime was equal to 0 and find that 34.657 number, and then plug all three back in, which worked out nicely because we'd already done 0 and 40. Or actually 0 was given to us. We had already found the population at 40, and then so we had to do one extra piece and find the population at that t equals 34.657. Okay. All right, guys, I hope that this has been helpful going through some more of these accumulation and definite integral using area type of functions. These are very common on the AP exam, so I wanted to make sure to kind of go over some of these with you as well. We're going to do quite a bit more practice and continue using these skills, so just make sure you're good, especially with the calculator as well, because a lot of times this relies on using the calculator to solve.